So far, in any time we've looked at angles in our whole school career, we've always talked about angles in terms of degrees. While degrees have been around for centuries, 4,000 to 5,000 years in fact, degrees actually become less useful when we start talking about trig functions. That would be sine, cosine, and tangent. But there is a relationship between degrees and the system we're going to talk about called radians. What we know is that there's 360 degrees in a full circle. And the symbol for degrees is a little circle, kind of in where the exponent spot would be if we were dealing with a number. The radian system is actually something that's been in use. You just haven't been told that it's the radian system, and it hasn't been used in the context of angles. It's been used in the context of circles. What we know for the circumference of a circle, some of you would say that it's pi times d, the diameter, but it's also 2 pi r times the radius. If we take the radius out of that equation, then there's 2 pi radians in a full circle. Usually when we deal with radians, we're actually going to talk about fractional parts of pi, so pi over 4, 3 pi over 6, things like that. When we're talking about writing down radians, because now that we have 2 units for angles, we need to be specific about which system we're using. The radian symbol is a little r, where the degree symbol would be, or there's no symbol at all. So if you see an angle with no symbol, then you have to assume it's in radians. The only time you can assume it's in degrees is when you actually see the degree symbol. We've got 2 formulas for converting. If we have radians and we need degrees, we take a radians multiplied by 180 over pi. Likewise, if we have degrees and want to get radians, take the degrees and multiply by pi over 180.